Good day, I am Chrisselle Leynes, and today we will be demonstrating a circuit based on given questions in our Module 1 exam. So the questions we will tackle is correlated to thyristors and transducers. And for the first question, for our first question, we are tasked to demonstrate the creation of the SCR phase control circuit with varying firing angles up to less than 180 degrees. And this is for our task 1. So first we will open our circuit with software, as this software is going to be used for demonstrating the circuit. Going to the library, we will get here our components. And for our workspace, I would like to show grid. So first of all, we will use an AC voltage source. I'll resize my video so we can see the library right here. Go. We will need 3 diodes. This is D1, D2. For our diode 3, we will use a thyristor. We will also need 4 resistors. A potentiometer. And a ground. So all of the components are already in the workspace. We will arrange the components. Potentiometer, R2, R3, thyristor. So in here, the most common type of thyristor is the silicon-controlled rectifier, or SCR. So when the cathode is negatively charged relative to the anode, no current flows until a pulse is applied to the gate. And for our D2, let's rotate this. And now we will connect the circuit. We will rotate the potentiometer. Lastly, the AC voltage source. We will change the values of our resistor. So R1 is at value 120 ohms. R2 is at 470 ohms. R3 is at 220 ohms. R4 is at 1000 ohms. And the circuit is already looking good. So for our last component is under test equipment under virtual instruments. We will add an oscilloscope. For our channel 1, we will measure it on our resistor 3. And for our channel 2, we will measure it on our AC voltage source. Okay, so we will add a graph. Change the maximum value to 15 and minimum value to negative 15. So now we will run our circuit. So as we generate the graph using oscillator, the output of the waveform is shown. We can see here that the blue waveform is for the sine wave from the AC voltage, and the red waveform is from the channel 2 connected to R3. Adjusting the variable resistor. As we observe, the red waveform, as the value is 0, it goes in phase at the positive half, and as the value of the variable resistor, or rather the potentiometer, as the value of the potentiometer increases, it creates a 180. We can see the red waveform. Its peak does not touch the peak of the blue waveform when voltage is negative. So the peak of the red waveform is at negative 9 volts approximately, as we can see here. That is for the demonstration. That is for the demonstration of the creation of the SER phase control circuit with varying firing angles up to 180 degrees. Thank you for listening. So for our task 2, we are asked to demonstrate the balancing of the Wheatstone bridge circuit with an LDR exposed at 650 lux, and potentiometer 1 is set to 30% setting. So first, we will open our Circuit Wizard software. We will use this again to demonstrate the circuit. And I'll be adjusting my window here so we can see the library and our workspace. Okay. For my workspace, I would like to show grid. So in here, we will use a 9-volt battery. We will also use 2 variable resistors, VR1 and VR2. We will use a normal resistor and also LDR. We will also include a ground to the circuit. This is very important. So now we will connect the circuit. Ground. And for our last component, we will add a test equipment on the virtual instruments. We will add a digital multimeter. So in here, we will change the values. So for our VR1, we should set it to 100 kilo ohms max, as you can see here. For VR2, this is also, okay, this is at 50K max. Change that. For our R2, we have 10 lux here. So we will change that as we run the circuit. And resistor 1, this is set at 15 kilo ohms. Okay. So we will connect the digital multimeter, or rather the voltmeter, between the 2 potentiometers. Actually, we will label this. This is potentiometer 1. This is potentiometer 2. We will connect the negative to the beneath our resistor 1. So as we run the circuit, we will change this to 30% setting. This will be at 100% setting. Our lux will be changed to, as indicated in the task, it is exposed at 650 lux. We will change value. So as I entered 650 lux, it goes by 654 lux. Okay, so we used a multimeter, specifically the voltmeter, and as we said, connected it between the potentiometers and the other resistors as well. With the value of the voltage in the voltmeter is at 5.62 volts. So this indicates that the circuit is not balanced, or the bridge is not balanced. So for the principle of the Wheatstone bridge circuit to be achieved, we need to make the value of the potentiometer 1 to reach nearly 0. Also, the bridge circuit can be used in one of 2 ways. The first is to adjust component values until the bridge is balanced. This is typically used to determine the value of an unknown resistor in the bridge when the other 3 resistances are known. So to achieve the principle of the Wheatstone bridge circuit, so as we adjust our value here. So as I decrease it to 0%, our volt display in the voltmeter is at 9 volts, which means it is not balanced. But as we max the value of the potentiometer at 100%, the voltage shows exact 3 volts in the voltmeter. With this value, this indicates our bridge is balanced. So what about the other potentiometer? Set this to 50 or 30 rather. As we decrease the value, percentage value, we get a value that is closer to 0. But as we increase the percent, we increase the volts, which is at 5.62. Both potentiometers, they change value as they change in percentage. They change in value in volts as they change value in percentage. So for potentiometer 1, we know that as the value percentage decreases, the value of voltage increases, and as the percentage increases, the value of volts decreases. While in potentiometer 2, as the value of the percentage decreases, the value of the voltage decreases, and as potentiometer 2 percentage value increases, the voltage also increases. So in here, we can see that potentiometer 2 has direct relationship for the percentage and the voltage, while potentiometer 1 has an inverse relationship for its value percentage to the voltage. And that is what I conclude from this Wheatstone bridge circuit exposed at 650 lux, and the potentiometer 1 is set to 30% setting. So that is my demonstration of balancing of the Wheatstone bridge circuit with an LDR exposed at 650 lux, and potentiometer 1 is set to 30% setting. Thank you for listening to for a demonstration of my circuits for my module 1 exam. Thank you.